In this video, I'm going to explain the properties of addition and multiplication and show how we can apply them to solve problems. So let's start out with a very basic addition problem. Let's start out with 3 plus 6, which of course equals 9. And I'm going to show you a model of what that might look like using dots. So I'll draw 3 in red and then 6 in blue. 1, 2, 3, 4, 5, 6. When I combine those dots, of course, I get a total of 9 red and blue dots. In fact, I can take these dots and I can flip around the order and put the blue dots first. I've now changed the problem. Instead of 3 plus 6 equals 9, it is 6 plus 3 equals 9. But the amount or the value of the dots does not change. There's still 9 dots there. So we can say that this characteristic of addition, that we can flip numbers around and add them in different orders, is a property of addition, and this is called the commutative property of addition. The commutative property. And the word commutative has a base word of commute. To commute means you travel from one place to another. So for example, you might commute to and from school every day or to and from work every day. So you're traveling to one place and then going backwards, doing the opposite of what you just did to commute home. If you look at our addition problems here, we did one direction here, 3 plus 6 equals 9, and then we did the backwards direction, 6 plus 3 equals 9. So we can say that addition is commutative because we can switch the order of our addends and still get the same sum. So let me move all of this over and let's see if we can do exactly the same thing with repeated addition, otherwise known as multiplication. So I'm wondering, does 3 times 6 equal 6 times 3? Well, I can draw a picture to find out. So I'm going to draw a 3 by 6 array, and that means 3 across and 6 down. And I'm just using x's for my array. So that's 5 down, there's 6 down. So this array that I just drew can be represented by the number model 3 times 6 equals 18 x's. But if I were to now rotate my array 90 degrees, I can see that it's no longer a 3 by 6 array, it's now a 6 by 3 array, but it still has 18 x's in it. So this demonstrates that 3 times 6 and 6 times 3 are equivalent. The number of x's did not change simply because I turned my problem around. So multiplication is also commutative. And the commutative property then says that the order in which we add or multiply does not change the result, the sum or the product. So does the commutative property work for subtraction or for division? Well, I can test that by again using my same problem with 6 and 3. Is 6 minus 3, is that the same thing as 3 minus 6? And I can model this using a number line. So in my first problem, I have 6 minus 3. Let's put this as 0. There will be 1, 2, 3, 4, 5, and 6. So if I start at 6 right here and I go backwards, if I subtract 3, 1, 2, 3, I end up at 3. So 6 minus 3 equals 3. So I'll do the same thing for my second problem. Draw a number line. And I'm going to start out on 3 with this one, so I only need to go to 3. And I'm going to go backwards 6. 1, 2, 3. And it looks like I'm going to have to add some more numbers to my number line because I'm not done yet. So 4, 5, 6. And it looks like this problem, 3 minus 6, equals -3. So clearly subtraction is not commutative, which means the order matters. The order in which I place the numbers very much affects the result. So I've answered my question. 6 minus 3 does not equal 3 minus 6. I can also test for the commutative property with division by asking myself, does 6 divided by 3 equal 3 divided by 6? And I'm not sure of that. So 6 divided by 3 means I have 6 of something, so I'm going to draw 6 circles right here. 6 divided by 3 means I need to share with 3 people, so I need 3 equal groups. There's 1 group, 2 groups, 3 equal groups. So 6 divided by 3, each person gets 2 of those big circles. If I look at 3 divided by 6, I'm going to start out with 3 circles. And I'm trying to share equally with 6 people, so I need to make 6 equal groups. And the only way that I can do that is by splitting each of these circles in half. And now my groups are right here. 1, 2, 3, 4, 5, 6. So 3 divided by 6, each person is not even getting 1 full circle. They're actually getting 3/6 of a circle, which is 1/2. So as you can see, division is not commutative. The order in which you place the numbers very much affects the result. So to review, the commutative property works with addition and multiplication only. It says the order of numbers, the operands in a problem, can change without affecting the result. And using variables a plus b equals b plus a, and a times b equals b times a, where a and b are any numbers. I'm now going to show you another property of addition and multiplication, but before I give you the name of that property and define it for you, I want to challenge you to add these 10 numbers that I've put on the screen here. Add these 10 numbers entirely mentally, and just pause the video and take a moment and see if you can add all of these numbers up entirely inside your head without writing any of them down. So now I'm going to rearrange the numbers, and I'm going to see if I can make this a little bit easier task for you. And as I'm rearranging these, see if you can figure out what I'm doing here, because I'm creating some sort of purposeful grouping. Now, if you have previously added the numbers up in your head, you might pause the video again and see if it's now a little bit easier for you to add these numbers in your head. Hopefully you notice that I grouped these numbers into numbers that will combine to equal some multiple of 10. So when I add these up, I'm getting a 10 every time. So now I can just add up these 5 groupings. 20 and 40 is 60. 60 and 60 is 120. 120 and 50 is 170. And 170 and 30 is 200. So did you get 200 when you added them mentally? Think about the strategy that you used when you originally added them mentally. Did you go in the order that I had them from left to right? Did you add from least to greatest? Or did you purposely choose which numbers you grouped together based on whether they were compatible numbers? This property of addition is called the associative property. And the associative property says that when I have a whole bunch of numbers and I'm trying to add them all up, any of my numbers can be grouped together in any way that I want. They can be partnered with any other number in that group. The base word of associative is associate. The word associate means to hang out with or to be around someone. So I purposely chose to associate numbers that worked well together. We call those compatible numbers. So I associated numbers that were going to add up to have a sum of something that ended in 0, some multiple of 10, because adding multiples of 10 is fairly easy to do in my head. In fact, the last step, 20 plus 40 plus 60 plus 50 plus 30, I could have made that even easier with the associative property by grouping the 40 and the 60 together, and then also grouping the 20, the 50, and the 30 together, because that would have given me 100 plus 100 equals 200. The associative property will also work for multiplication. So if we look at 4 times 5 times 2, we can think of this as 4 times 5 and then times 2. Or we can think of it as 4 times 5 times 2 first. We can check to see if this works. This would be 20, then times 2 is 40. This would be 10, then times 4 would also be 40. So 40 equals 40. This property will become very useful with multiplication, especially later on when you start trying to calculate the volume of things like rectangular prisms, because you'll want to look for compatible numbers that you will multiply first. So let's see if this property will work for subtraction or division. So let's see if the associative property works for subtraction or division. The associative property says I can group numbers however I choose. So let's do the problem 10 minus 5 minus 3. And I can group the 10 minus 5. And then if the associative property works, I should be able to also group the 5 minus 3, and this should be a true statement. So let's check this. 10 minus 5 is 5. 5 minus 3 is 2. 5 minus 3 on the other side is 2. And 10 minus 2 is 8. 2 does not equal 8. So this is not a true statement. So the associative property does not hold for subtraction. Let's now check for division. Let's say I have 18 divided by 6 divided by 3. If the associative property works, I should be able to move the parentheses wherever I like and group it in any way I want. So 18 divided by 6 is 3, and then 3 divided by 3 is 1. 6 divided by 3 is 2, and 18 divided by 2 is 9. 1 does not equal 9. So just like subtraction, the associative property does not hold for division. This isn't really surprising because we've already learned that subtraction and division, the order in which we do the operations, very much does matter. And if we move around the numbers in any way, we will get different answers. And because the associative property means that we are grouping different numbers together, and we're doing things in a different order than left to right, it means that we're not going to get the same answer with subtraction or division. So to recap, the associative property works only with addition and multiplication. It says that numbers can be grouped in different ways. So for addition, we can group A and B together, or we can group B and C together, and we will get the same sum. In multiplication, we can do the same thing. Multiply A times B and then multiply that product by C, or multiply B times C and multiply that product by A.